All right, guys, so let's carry on with the VMware vMotion topic and then what we can do with the next topics. So here, I'm going to put the diagram and then we're going to try to understand what is vMotion or virtual machine migration. And I'm just going for the proper diagram on the other side. Okay. Right. So vMotion is the migration of virtual machine from one hypervisor to another. So if so suppose there's a virtual machine here, and that virtual machine has this virtual machine is on top of a hypervisor, right? And the hypervisor has a lot of other virtual machines as well, suppose. So suppose there are actually 5 or 10 virtual machines here, right? So now there are so many users who are connecting to these virtual machines. Connecting, right? So suppose there are 500 users connected to this virtual machine, 1,000 users connected to this virtual machine, 2,000 users connected to this virtual machine. So during the peak times, maybe 11 o'clock, maybe 1 o'clock, the users are complaining that the virtual machine that is, suppose they are trying to pick up a file and the file server virtual machine users are saying that they cannot log in. So the virtual machines, uh, the users are saying that they cannot, they're connected to the virtual machine, but they are having very, very slow performance, right? So it's terribly slow performance. So you investigate and you think that, and you find out that there's a lot of RAM being utilized here. There's a lot of CPU being utilized here. And RAM has actually reached, suppose it's 88% RAM is being used, and CPU is also nearly 85% CPU is being used, and all the users connected to these machines are actually seeing a degraded performance. So they're opening the files, and especially this file server users, they are really, the users are connecting and they cannot open the file, or when they open the file, it is unacceptably slow. It's opening really slow. And the performance of this virtual machine and thousands of users, or maybe 1,200 users, suppose, are connected here, and they're all complaining that the performance is really slow. You investigate that, okay, it's peak time, 5 or 10 virtual machines more are here, and users are connected to those 5 or 10 virtual machines as well. And because of peak time and because of so many users using that, so the file server, users connected to the file server, they are experiencing very bad performance. And it takes time to open the file, it takes time to close the file, it takes time for everything, right? So now what do you do? Either, so how can you make the performance of virtual machine users, or the performance of the virtual machine here, perfect? So now you also investigate that other hypervisor, it has RAM is being used up to just suppose 40% of RAM is used. and CPU is also slightly being used, or comparatively less CPU is being used. Suppose 50% of CPU is used, and the rest is all free and available, right? So you then realize that, okay, if I move this virtual machine from the heavily used hypervisor where 88% of RAM is being used and 85, and the users of the virtual machine that is being hosted on this hypervisor, the users are complaining that it's too slow. So you realize that if you move this machine, migrate this machine from the slow hypervisor to faster hypervisor, then obviously the machine's performance will increase. Machine will get 60% of RAM at its disposal and 50% of CPU at its disposal. So this means that the performance will be very good if you move or migrate the virtual machine from the slow hypervisor to the faster, comparably faster hypervisor, right? So then if you decided that, okay, if I migrate the machine, then the users will have good performance. So then the next question is, did you configure the two hypervisors of the VMware environment so that the virtual machine could be migrated? So how can you migrate? And one way is that you can shut down this machine, disconnect all the users, and then move this virtual machine from one hypervisor to another. But that requires a downtime, right? So that's not a very productive option. So like today, the whole downtown core was out of electricity, and my colleagues, thank God today I was connecting from home. So my colleagues who were supposed to go today, so our office is on 42nd floor. So they had to come down from the 42nd floor. So that was like, whoa. But anyway, the thing is that yeah, if you shut down the virtual machine, it's going to distract all the users. Suppose you move and it takes like what, um, uh, 10 minutes, 15 minutes, 20 minutes, because maybe you're moving the hard disk of this virtual machine as well, virtual disk of this virtual machine as well, right? So, and then you power on the machine, then you tell the user, so maybe 1 hour of productivity is gone. So you want to move the virtual machine without any downtime, without any downtime. So a few seconds of maybe the machine is just frozen, and then again the user get to use the machine, but this time it's faster. So yes, we can have the virtual machine migrated if it is shut down. We can have virtual machine migrated or vmotioned if it is suspended or frozen. And we can also have virtual machine migrated when it is powered on. So that's the one of the main features of VMware that got the VMware a lot of customers, that and a huge amount of companies started adopting to VMware last decade, because you can actually migrate a virtual machine while it is being used, while all end users are connected here, and the virtual machine can migrate from one hypervisor to another while the user are connected. So user connections are also moved, and the virtual machine is moved, and placed from it is placed from the RAM of this hypervisor to the RAM of this hypervisor. The virtual machine and memory contents actually travel. So this is then pretty critical to know that how does it all happen. Also, there is another scenario to this, that suppose, well, it's not suppose, every virtual machine has to have a virtual disk where the data is living, right? So the data is living inside a virtual machine. It's inside the virtual disk of the virtual machine. Now remember that virtual machine always powers on top of RAM. The virtual disk is placed on either a shared disk over the network, or one coming from SAN, or if if you did not follow the best practices, then you might have put the virtual machine, virtual disk on the data store that is on top of a local disk. So that is already not recommended. So obviously a best practice or professional environment would have SAN here, SAN solution, some kind of SAN solution here, and your virtual disk will be over the network, right? Now this data store is accessible from this virtual machine, this hypervisor. This data store is accessible from this hypervisor, right? And this whole LAN or data store is accessible from this hypervisor as well. Because we attached this one LAN to all three hypervisors, when we create a data store on top of it, obviously this data store will be accessible from this hypervisor, and this hypervisor, all three hypervisors, right? So that's the thing, that if the virtual disk has to move or migrate as well. Right now I'm saying only the virtual machine memory contents move. They are very small in size. So that's why in few seconds, the virtual machine gets migrated from one RAM of one hypervisor to the RAM of other hypervisor. But if virtual disk had to move as well, suppose you were moving virtual disk as well as virtual disk will move from one data store to another data store, and virtual machine will move from the RAM of one hypervisor to the RAM of the other hypervisor. So the main thing in vMotion is that the virtual machine moves from the RAM, as I just mentioned, of one hypervisor to the RAM of another. But the virtual machine virtual disk does not move in this migration, or what we call vMotion, right? So the virtual disk does not move. Why? And what would be the reason that you would not want a virtual disk to be traveling over the network and be migrated as well? Because virtual disk is huge in size, right? Some virtual disks are like 2 terabytes, some virtual disks, even 50 GB, 50 gigabyte, or 20 gigabyte, right? Guys, this is critical from my internet service provider. So just give me a second. I'll just hello. Oh yeah, resuming. Okay, so yeah, I thought that my bell connection has some issue or something, but it's okay. It's just all right. So as I was saying that the virtual disk must not move when the migration is going on. The virtual disk could be large in size. It could be 50 GB, it could be 80 GB, it could be 1 terabyte, or it could be 100 GB, 500 GB, 1 terabyte, right? So even 50 GB disk, it will take some time to travel over the LAN to be migrated from one data store to another, right? But that would be really counterproductive. It would make the end users connected to machine end users experience very slow and very low. So the thing is that the virtual machine needs to be only moving from the RAM of one hypervisor to another, and only the memory contents of the virtual machine should be moving. The virtual disk should not be moving. Only then you can achieve few seconds of delay in the migration, and that's all. Few seconds of time is just needed to migrate a virtual machine, and the end user connection, end user information as well, that is loaded on the memory, and whatever files were open, that is loaded on the memory. So overall, this much gets moved to the other hypervisor's RAM, and that's it. So, okay, if the virtual disk is not moving and only virtual machine is moving, then when the virtual machine actually reaches here, so what happens to the virtual disk? It has to stay connected to the virtual disk to offer data to the user. Suppose it reaches here, right? The FS, and this file server reaches here. So because this hypervisor has connectivity with the data store, with the same data store that this hypervisor had connectivity with, so the virtual disk that is living on this data store not only is accessible from this hypervisor, but it is also accessible from this hypervisor, because this one is connected, the same one is connected to this hypervisor, and the same one is connected to this hypervisor. So obviously the data store will be accessible from both hypervisors. So what happens is when the virtual machine moves, there's a very, milliseconds or few seconds of cutoff here, that the suppose virtual machine is here. So virtual machine was connected through this hypervisor to its virtual disk. So as soon as it reaches here, so now that virtual machine has cut off its connection through this hypervisor and will establish in seconds a connection to this virtual disk, because this hypervisor also has a connection to the same data store that this hypervisor had. So the virtual disk is accessible for this virtual machine from this hypervisor. If that virtual machine is here, it still can connect to its virtual disk from the other hypervisor as well. So that's why it makes the migration very fast, because the virtual disk does not travel, does not move, it just stays there. Only the virtual machine loaded on the RAM with the memory contents or whatever information is that, oh, okay, there are 1,000 users connected. Some users have opened the file, some users have closed the file, and some temporary virtual machine files. Only they move, and they are small in size, and they move real fast. And so that's how during the peak times, a powered on virtual machine with maybe 1,000 or more than 1,000 users connected and working, when the virtual machine moves, the end user's connectivity information also moves, and the users are still connected, and the machine they're connected to is now on a faster hypervisor. So all of a sudden, while they were having very slow file opening and file closing here, they then see here, all of a sudden the files are opening fast, and they can type normally, they can close the file normally, they can save on the file normally, right? So all of this happens because only virtual machine memory contents move from one hypervisor to another, and virtual disk of the virtual machine stays and is again connected to the same virtual machine from a faster hypervisor, right? And while the virtual machine moves, it's few seconds. So yes, there's a few seconds of frozen screen. Did I say screen? Okay, so it's a few seconds of frozen screen, which means if they were clicking the file, or if they were working on the file, all of a sudden there's no response, and they click, 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 and nothing happening, as if the file is frozen. But all of a sudden it starts working, and now it is just real fast. It's normal, right? So, and they would have no idea that actually the virtual machine they were connected to had been migrated from a slower hypervisor to a faster hypervisor, right? So that's the overall idea behind vMotion, that you can actually move virtual machine from a slower hypervisor to a faster hypervisor. The vMotion can so vMotion kicks in if there is a degradation of performance, right? So virtual machine, the vMotion feature kicks in or is useful. Now, kicks in means it automatically comes into action. No, virtual vMotion can be used if there is a degradation of performance on hypervisor. On hypervisor. right? But vMotion has nothing to do if hypervisor crashes. So you should know, and that's the same discussion, kind of same discussion that's we're gonna have when we are talking about a feature called DRS or Distributed Resource Scheduler and HA, which is high availability. So those two features, what's the difference between them? So we're gonna talk about that. But this, suppose the hypervisor actually crashes. So there will not be any vMotion possible. The virtual machine will not be vMotioning if the hypervisor at once crashes for some reason. Suppose the RAM is corrupt, suppose power supply was cut off and it just crashed right away. So this has nothing to do with vMotion. vMotion can only happen if a hypervisor is powered on, but slow. Okay, if it is slow, yes, you can do a vMotion, but if it is shut down or turned off for some as a result of some kind of disaster, so machines will be effectively shut down. vMotion cannot do anything here. That feature is called fault tolerance, where you have a virtual machine here as an active and its passive partner is on the other side. And it is whatever is being written here is being synchronized right away then and there to the other machine as well. So when this hypervisor crashes, then the active machine is not available. All at once, all the feature services and all connectivity information is shifted or failed over to the other hypervisor. So that feature is called fault tolerance or FT. But vMotion cannot do anything if the hypervisor is turned off or it just crashes. So vMotion cannot help you with that. The hypervisor has to be powered on for vMotion to do anything, right? Okay, so we get data, right? So there's more information that we really need to know as well. And I'll just put that in the slide that I will share with you. So the students that are not attending the class, I mean, they still have to upload the screenshots. And if I don't see screenshots, they don't get anything, right? Suppose their lab is not ready. They have to take a screenshot of my screen. And if they're not there in the class, obviously they will lose their marks. So not attending you might really lose marks. So please spread the word to others. I know the weather is very good, or maybe you have exams or something, but obviously you have to attend the class. Okay, so let's go ahead. Now, migrating virtual machines, there are 4 types of migrations here. This slide talks about it, but this also talks about it. There's a cold migration where the machine is off and you can migrate. Then there's a suspended migration, which is the machine is suspended and you can migrate. There's the vSphere vMotion, which is the machine is on, and we just talked about that. And you can migrate. Then there's vSphere storage vMotion. What is storage vMotion? Storage vMotion is what I just mentioned before, that the virtual disk of the virtual machine is migrated from the data store 1 to data store 2 or 3, whichever. So across the data stores, if the virtual machine's files and virtual disk has to be moved away, then it is called storage migration or storage vMotion, right? And cross-host vSphere vMotion is that suppose you have decided that the virtual machine will change hypervisors and its virtual disk and other files of the virtual machine will change the data store. Suppose you planned the 2 migrations in one go, so that is called then cross-host vSphere vMotion, where virtual disk moves from one data store to another, and at the same time, virtual machine moves from one hypervisor to another hypervisor, right? So that would be then call that. So there's one more thing that we need to know, and that is this CPU compatibility. Oh, what is this? What has CPU compatibility to do with migration? So if we go back to our diagram, the vMotion, the virtual machine can migrate from one hypervisor to another hypervisor if this hypervisor's CPU belongs to the same vendor and same family of products, right? Of same family of CPUs. So suppose this CPU is Intel and this CPU is non-Intel, right? Uh, seriously, forgot the name of the other CPU manufacturer. What's the name of the other vendor? Serious? That's so easy. It just went out of my mind. Anyway, and I'll show you there the two major CPU vendors there. And one is Intel, the other one is, it's so easy name. Anyway, AMD, there you go. Thank you, Nicholas. So yes, if other one is AMD and this is Intel, so migration cannot continue, right? If it is different processors, because virtual machine is using the type of processor, when it is migrated, it expects exactly the same environment. That also means the processor has to be exactly the same company, and the processor features that the processor is offering has to be either exactly the same or maybe slight difference because of the family of CPU. So generation of CPU, as they say, right? Not only that, the CPU vendor and generation must be same. This is a condition that has to be met. Otherwise, vMotion will not happen. So it's just going to give you an error that no way. The other hypervisor is, suppose it's Intel and Intel, but the generation. So generation one, generation two, generation three, four, it goes on, right? It goes on with all the products. There's generation there. So suppose this is not AMD, this is also Intel, but generation, this is Intel Gen, suppose 11, and this is Intel in Gen 12. So again, the features of generation 11 CPU, Intel CPUs are architecture-wise more, they have more differences between each other, between the processors of generation 12 and generation 11. So I'm just making that up about generation 11 and 12. Maybe they don't exist. Maybe it has reached maximum of generation 9 or 10, or maybe 7 or 8. I'm just giving an example here that suppose the generations are different. So when there's a generation difference between two Intel CPUs or two AMD CPUs, it has that much difference, which is unacceptable for a virtual machine to be migrated from one hypervisor to another. So VMware has put those conditions here that when you're purchasing a hypervisor, make sure that they're same vendor, and also make sure that they have they belong to the same generation of CPU. And it could be, suppose suppose there's generation 11 Intel CPUs, right? And generation 11 Intel CPU released in 2019, right? And then generation 11 with slightly more changes, another generation 11 CPU, because the main architecture may be the same, slightly more features may have been introduced, so they released it in 2020. Then same generation 11 main architecture, majority of the architectural features are same, few features are different, so they still consider this as generation 11 CPU released in 2022. So they could be all belonging to the same generation, but having slightly different features, right? But the main architecture could be the same, but generation 12 CPUs might have some architectural differences as well. VMware then decided that, okay, if the differences are of that level or of a certain level, which is, more difference between two generations of processors. So virtual machine will not then be able to be migrated if they belong to separate generations. Because virtual machine totally, uses many of the features of the processor for its working, for its tasks that are coming. Processor are taking the tasks and performing them. So if many of the features that are available in one processor are at once when they move to the other hypervisor are not available here, so obviously virtual machine might stop working even, right? So that's why if you want to keep it smooth, that the end users, 1,000 or 12 or 1,500 users are connected here and the virtual machine moves to another hypervisor, you want that virtual machine to be smoothly working here as well, right? So you don't want any disruption. Virtual machine doesn't find any CPU features and it stops or it just starts giving errors. Some of the tasks do not work anymore. So that's why, in order to avoid all those surprises of disruption of work, then you have to make sure, if you want to enable vMotion, you must have same vendor processor and at least same generation of processors between the two vendors. So suppose your company purchased 10, they had a budget and they purchased 10 hypervisors in 2021, right? In 2022 or 2023, they were expanding, more users came, more services they started offering, and they realized that they need more hypervisors. But they realized that Intel has stopped producing generation 11 processors and they purchased 10 hypervisor or physical machines in 2021, which belong to generation 11. And now in 2022, when they're trying to purchase, they found out that, oh, it's totally, generation has changed and Intel CPUs are not available from generation 11. So you are forced to buy generation 12 CPUs based hypervisors or physical machines, right? So in that case, then you will have to create, like you can configure vMotion. Suppose those were 10 separate hypervisors. You can just make a cluster of those 10 separate hypervisors and make another cluster of the older generation. So you can group them together according to generation and enable vMotion between them. But generation 12 vMotion cannot happen to 11 and back and forth, right? So the strategies could be different if generation is different for hypervisors, for the CPUs. Okay, so vMotion is fully affected by that, and we get to know that too. Now, cold migration, there's a type of migration called cold migration where the virtual machine is actually powered off. And even if one hypervisor belongs to Intel and other hypervisor CPU belongs to AMD, it doesn't really matter because the machine is off. It's not using any of the sensitive features of the CPU, so you can just migrate the virtual machine from one hypervisor to another. But wherever and suspended, if the machine is suspended, it is using many of the features, and when it's frozen, it also keeps into its information that what kind of features it was using. So must meet compatibility requirements of CPU. If you suspended the machine, which is totally different from shutdown, whatever tasks were open, whatever windows were open, they're frozen, and whatever features of CPU they were using, it has to be those features when they are resumed back or unfrozen. So that's why suspended machine has to meet the CPU compatibility requirements. vMotion, when the machine is powered on, obviously it has to be same vendor, same generation of CPU. And storage is different. So the CPU compatibility does not apply because it's just virtual disk moving from one data store to another data store. And it's cross-host. Yes, virtual machine is also moving, virtual disk is also moving, but virtual machine is powered on and moving, so it has to meet CPU compatibility requirements. All right, and then CPU constraints. So this is kind of a little in-depth that CPU characteristics, clock speed, cache sizes, hyper-threading. It's all in-depth CPU features that are sought, that are supposed to be there, matching in the other hypervisors CPU as well, and whichever features use whatever, or whichever features offer whatever services like multimedia services, then you must have these features. instruction sets contain many small differences here, and then virtualized away by the VM kernel. So there are many processor features that you can see, and you can just research on it more. But the thing is, the main thing that we need to understand is that the processors need to be belonging to same vendor, same generation. And I'm going to show you that in our, okay, well, before we go to that, I'll be, so 2 GB power on. I'll just power on those guys, or resume, not power on. 10 GB this. I have 32 GB, but I still put it on 10 GB, seriously. Okay, while majority of you actually have 32 GB laptops, so that's very good. So I powered on those machines. What I was saying that I'll be showing you how it detects the hardware. The vCenter will detect your hardware, laptop hardware. For one lab fault tolerance, you will have to enable a feature called EVC, Enhanced vMotion Compatibility, and that will detect your processor. And because on one same laptop, we have multiple hypervisors, so obviously all hypervisors will detect the same processor. So you will be able to do vMotion easily. If you had different physical machines, then vMotion would be not possible if their CPU don't belong to the same generation. So what do we need to do to implement to configure the hypervisors so we could migrate virtual machines from one hypervisor to another? So CPU compatibility, this is good. This is already check. Obviously, it's one laptop, so one CPU is available for multiple hypervisors. vMotion interface, minimum 1 GB adapter. So the network card adapter should be 1 GB now. All latest laptops are 1 GB or more. They're supporting the speed, 10 GB as well. Shared central mass storage. So we do have software SAN available, so we're still good. We qualify these above three features. Same naming for virtual port groups for two hypervisors. So what we are planning to do here is that we're going to migrate a virtual machine from one hypervisor to another, and then back as well from this hypervisor to the first one, right? So the virtual machine will migrate. So in order for that to happen, we need to have the port groups with the names should be same. So the network should be same. Although, if suppose the port group name here is 1 and the port group here is actually 2, it still works. It just stops and tells you first before migration, hey, the network configuration on the destination host where the machine is about to migrate, its destination network or port group name is this. So you just have to accept it, and it still goes. But if it's the same name, that is best practice. But if it is different name, like, it still works. Sufficient resource. So when it says virtual port groups are same, so I'm just going to go back there, and I'm going to check then the configurations. Okay, so since I resumed it, so it's going to kick me out now. So I'm just going to refresh this after unfreezing the virtual machine and proceed to CSA. So it's small ABC, capital ABC, 2.23, the 2.23. Okay. So I'm in now, and I'll go to the menu here, and I'll go to hosts and clusters. So it's this link here. And then I'm going to go for E6i2, because I want to migrate virtual machines from E6i2 to E6i3, right? So E6i2 is here. And if I go to virtual switches, and then I go to the port group. So there is one port group here with vSwitch 0 in E6i2. vSwitch 0, VM network. The other one is actually VM kernel port, right? So we talked about that in last class. So I'm just going to go to the ESXi3 just to check that. Does it also have vSwitch 0 and does it also have a port group called VM network? So I'm going to go to ESXi3 now. And yes, it also has vSwitch 0 and the port group called VM network. Suppose there was a different named port group, it's still going to work. So it's okay. So yes, we meet this same naming for virtual port groups as well, the requirement, and then at least one vSphere Essentials Plus license. Actually, we have a trial enterprise license, which is bigger than Essential Plus. So this is just a minimum. No, but this is not the full list of requirements. So I'm just going to go to the next page. And again, it kind of mentions the same requirement. Oh, what's going on here? Okay. So, well, actually, that's the same one. Our CPU requirements are okay. Yes, it's okay. Confirm our network settings. When it comes to same name port groups, so we're good already. And remove all the other switches. Last time we removed all the switches. And make sure our VM has an operating system. Well, it's good to have an operating system, but if you don't have it, still the rules are same. Migration or vMotion will work with or without an operating system, right? It's going to be the same exact procedure. So now this is one requirement that we did not meet. So I remember that I was saying that VM kernel adapter uh, introduces or offers network features, network side of features for all advanced services. So we're about to implement an advanced service called vMotion. So you want the networking side of vMotion to be configured. For that, you need to configure VM kernel adapter. VM kernel adapter will need to be configured on ESXi 2 and 3. So on this ESXi, VM kernel adapter has to be configured. On this ESXi, the VM kernel adapter has to be configured. And once they're configured with vMotion capability, then we can try to vMotion or migrate a virtual machine from one hypervisor to another. So I'm going to do this. I will be going to my ESXi2 first. And I need to create a VM kernel port or VM kernel adapter, which will help configure the hypervisor to support vMotion, right? So how to do that? I'm going to go to the E6i2. I'm there. I'm on virtual switches, and under the virtual switches is VM kernel adapters. So VM kernel adapter introduces or offers networking features to advanced services. So one advanced service we discussed last time was management network VM kernel port or adapter. And because of this, we are remotely connected to the hypervisor and managing it. So thanks to this VM kernel adapter called management network. The second VM kernel adapter will introduce vMotion feature, right? So I'm just going to click add networking here. For E6i2, then the same procedure has to be done for E6i3. Suppose you have 200 hypervisors in a big company. So you will have to configure whichever hypervisor you want the vMotion to work on, whichever, suppose all 200 hypervisors, you should be able to migrate virtual machine on. Any one of the hypervisors among 200 hypervisors, you should be able to migrate virtual machines on. So if you want that, then you have to go through this process on all 200 hypervisors, right? So I'm just on this screen, and yes, I want to configure VM kernel network adapter. Last time we used virtual machine port group, and we used this feature, physical network adapter, but from outside. But here, VM kernel network adapter. No, this is physical, right? So VM kernel network adapter. We're gonna use. We're gonna introduce this feature now, vSphere vMotion, right? So I'm gonna select that and next. And another best practice is that why don't we introduce another standard switch? So we already have a vSwitch 0, right? And all virtual machines are connected to vSwitch 0. Okay, that's good. But and now vSwitch 0 also has two network adapters, right? So suppose there was a huge traffic coming from 5 or 10 virtual machines that are all connected to vSwitch 0, and vSwitch 0 is connected to two network cards. So all the traffic incoming and outgoing for of virtual machines is going through these two network adapters. While if we add vMotion feature to this vSwitch 0, so vMotion traffic of this virtual machine will also go through this vSwitch 0 and through those two network adapters. So it is already overwhelmed with the traffic of the virtual machine. Now we should not be overwhelming. Although technically, yes, we can just configure vMotion on this vSwitch 0. But what we will do is we will just create another switch. We will create another switch, right? And that switch would be vSwitch 1. And this vSwitch 1, so this is just best practice. We could still do that on vSwitch 0 as well. But just to show that how, if we want to implement best practice, then how to do it, not vMotion, vSwitch 1. And why are we creating vSwitch 1? Because we don't want to overwhelm these two network cards with vMotion traffic while they are already putting up with all the virtual machine traffic, right? So what we're going to do is we're going to introduce two more. Remember, we have 10 network cards. So suppose in your production environment, virtual machine has actually 8, 4, 8, 4, 6, 8, 12 network cards. So you can just redirect the traffic of the vMotion through the vSwitch 1 to another set of network adapters. So these network adapters will offer dedicated bandwidth just for the vMotion service, while the virtual machine inbound and outbound traffic it will go through vSwitch 0 and these other two network adapters. So the benefit of introducing another virtual switch is that we can introduce another set of network adapters. So we could regulate the heavy traffic for vSwitch through these two network adapters and not overwhelming these network adapters as well. Although technically we can do that too. So that's what we're about to do. We're going to create a separate switch. We're going to introduce two separate network adapters and connect this switch to separate network adapters and then configure vMotion. Although, again and again, I'm saying we could do that still on vSwitch 0 technically. So if I go back here, I could use select existing network switch. So I'm not going to do that. I'm going to go for new standard switch. This is existing network, but this is existing standard switch. I could have gone for this, which is the vSwitch 0, but I'm going to go for another switch, and it's maximum transmission unit or MTU, where we don't touch that unless we have a good reason. So I'm just going to click next, and then I need to add two network adapters extra because I have in my machine, suppose in your physical environment you have 8 or 10 network adapters, so just go here and then just choose two more, right? So I'll just select two more and press O and K, and then next. Now it says, okay, so you're creating a new switch, new virtual standard switch, and you have actually dedicated two network cards for that new standard switch. So what do you want to name that label, network label? What do you want to name this VM control port? So we say that we're going to name it vMotion. And VLAN ID, no, we're not creating a VLAN. Is it IP6 or IPv4? It's just v4 traffic. MTU, we're not changing that. TCP/IP stack, you can see that there is vMotion separately available. So what it means here is that these are all advanced features, right? They all generate their own traffic. Fault tolerance, I was telling you, FT, that you have one virtual machine, one active virtual machine, one passive virtual machine on another hypervisor. That separate lab we're going to do. So you can enable all these advanced features and they all generate a lot of traffic of their own. But then vMotion is such a sensitive service because virtual machine needs to move correctly from one hypervisor to another hypervisor. So do you want only vMotion? See, all others have grayed out. Now, technically, you cannot select any others. So you're dedicating this TCP/IP stack, this TCP/IP protocol, just to support vMotion traffic. And in future, if somebody wants to come, hey, I want to enable FT as well, fault tolerance. Oh, I want vSphere replication as well. I want vSAN as well, through the same two network cards and virtual switch one. So you say that no, vMotion is a very sensitive process. I don't want any other service to be running on this. So then you can actually choose from here. Otherwise, if you go default and then you select this vMotion, yes, you can do that, but you can still introduce more features. Suppose you want to introduce in future more features, more of these you want to select in future, right? And because you have only 4 network cards, suppose 2 network cards are connected to vSwitch 0, and the other 2 are only connected to these all extra services. So if you have just 4 network cards, then yes, it's okay. But if you have a 6, 8, 12, 16, 14 network cards, then go for dedicate just 2 network cards only for vMotion, because it's a very sensitive and very, very useful feature. Obviously, whenever there is a degradation of performance, the hypervisor is slow, just migrate the virtual machine to a faster hypervisor, making the end users happy by increasing their productivity and giving them speed whenever they want. All right, so vMotion here, and so I'm dedicating this. So this means also in future we cannot enable other advanced features here. So I'm just going to click next. And yes, well, it can get an IP from DHCP in our lab environment. We can support that, but just to follow best practices, we're going to go for more static IP. Now, those IPs which we haven't used in this network. So I'm just going to go to DNS here just to check out that. First, I'm going to go to the server level, refresh. Oops, what happened? The folder, one of its children. Okay, I'll just close that. Oh, something was open here. This one. Now it's refreshed, and then I'll go forward look at zone, and then I'll check that what IPs I haven't used yet. 10, 1, 2, 3, 10, 4. Until 4 I have used, so 5 till 9 are available. Okay, so I'll use 5 and 6, or I could just go for 11 or 12 or whatever, right? Whichever IP that has not been used here yet. So I'll go for 5 and 6, 5 for hypervisor 2 and 6 for hypervisor 3, right? As the static IPs to be offered to vMotion service, right? So I'll go for 192.168.200.5, and yeah, 255.255.255.5.0. Okay, default gateway does not change. Yep. Yeah.
So can you go back to
Back here.
Step 1? I missed some steps.
We're more back.
Yeah, from one. Yeah, it's good, right? Yeah.
So the first one, and then next is the third one.
Right.
And then and you have to go plus sign here and
Right.
go for whatever next 2 network cards available. Next. Then type here, rename it to vMotion. Don't change anything else other than this. So I chose vMotion, and then all will be grayed out. Although it's not compulsory, but this is the best practice. And then the screen where we are now. Right?
Okay, yeah.
Cool. Yeah, if you want to see that screen, this is the one. Okay. Next. And yeah, once the IPs are given, then so this is the unused one. So I'm putting it here as a static IP because this is a critical resource. So I'm not relying on DHCP, although from DHCP we can give also IP and then reserve that IP so nobody else uses that. We can do that too, but I'm just going for static. Next. That's it. So this is all we need to do with on E6i3 as well, all these steps. And there the IP will be 200.6. So I'm just gonna click finito. Okay, so here, now you see VM kernel adapter 1 that has introduced networking for advanced feature called vMotion. Now I'm gonna go for E6i3 and I'm gonna do exactly the same steps. So E6i3, I'm on VM kernel adapter here as well. And here I'm just going to create exactly one more VM kernel adapter, new switch, two new dedicated network cards here as well. So VM kernel network adapter, it's selected. Next, I'm going for third one, new standard switch. Next, then I'm going to give it two dedicated network adapters. ONK. Next, and then so I'm just, I could do just click here and next, but I want it to be dedicated just for vMotion. So the TCP/IP stack will be offering networking services only to vMotion. Next. And I'm switching to static IP. And there, 192.168.200.6 tab 255.255.255.0. Next. Finish. That's it. Okay, so VM kernel adapter added for an advanced feature called vMotion. This is the same thing we're going to do for another advanced feature called fault tolerance, and then for vSAN as well. Okay, so once this is done, we can check our list of prerequisites. So yep, this is done now. And make sure we should have two port groups, one for management. Yeah, there are just two port groups, one for virtual machines and one for remote management or management network. And remove all extra switches. Last time we did that. Done. Make sure our VM has operating system. So we can use an operating system based virtual machine as well as empty virtual machine. So let's create a data store on our storage. Well, we already have 3 data stores, so this is also done. Let's move our VM with OS installed. Okay, so let's we're gonna check now how to migrate our virtual machine from one hypervisor to another. So the 4 types we're gonna try is, first we're gonna go for cold migration, then we're gonna go for suspended migration, then vMotion, then cross-host vMotion. We don't need to do that because storage vMotion, because we're going to do that exactly here as well, right? So we don't need to do the 4th one. 5th one also includes the 4th one and the 3rd one. All right, so cold migration, if we go for that, how does it look like? So cold migration is that the virtual machine is stopped, right? So virtual machine is stopped here. I'm going to go for VM02, and I'm just going to right click here, and I'm migrating this virtual machine from E6i2 to E6i3 while it is turned off, which is not, very important. It's not that useful. It will be useful if it is powered on and we are able to migrate. So we're going to do that too. But first, the cold migration. So I'm just going to right click here and go to migrate. Change compute resource only. We're just changing the hypervisors. I'm going to click next. And then it asks that which hypervisor is the destination. Well, it's on 2. It's on 2, E6i2. So we want to move it to 3. So 3 is our destination. So what happens is sometimes you don't see the other hypervisor. Suppose you don't see the other hypervisor. You know what will be the reason? if suppose you don't see the 2 hypervisors, suppose you had 5 hypervisors, suppose you had 10 hypervisors, and all 10 are not showing here, and even missing. So the reason is ridiculous. I mean, we found it the hard way in one class way back. But I'm just going to cancel out from here. Suppose, no, actually, I see 2 hypervisors, right? I see 2 hypervisors here. But suppose you don't see 2 hypervisors. Then what could be the reason? So I'm just going to cancel out just to show that if you don't see in case you don't see the 2 hypervisors, you need to go here, edit settings. Now we don't have to do that, or I don't have to do that because I see 2 hypervisors. But if in case you don't see the 2 hypervisors, then you just have to make sure that your CD DVD is not mapped with the ISO of Windows 2012, Windows 2016, 2019, whichever Windows. But if the Windows ISO is mapped to the CD DVD of your virtual machine, then it's not going to migrate. Because if the ISO is mapped to the CD-ROM of this virtual disk, then it expects that it would be still connected to that ISO when it reaches on the other side. So VMware has just put a restriction here. If you have mapped the ISO Windows, any Windows here or Linux here or whatever, whichever operating system, if there's anything mapped to the CD DVD of a virtual machine, then you cannot migrate. That's one of the main rules here, right? So now, you know what? That first virtual machine actually has, if I go here, this is the one with the operating system, right? If I go edit settings here, yes, there's an ISO mapped to this one. So why don't we try that and check if the error comes or not? What is the error? Error is that you won't see the destination. So you cannot migrate if you don't see the destination, right? So I'm going to try with the operating system one, but it has ISO Windows 2019 attached to it as well, right? So I'm going to click migrate and go to change compute resource and click next. It shows both, and my destination is inside through. I'm just going to select that. Now it says there are compatibility issues that need your attention. So it may not let you go ahead if you have the ISO Windows 2019 or 2022 or 2016, 2012, whichever. So if I go to show details here, there you go. It says here device CD DVD drive 1 uses backing data store 1, and it has this, see this ISO of Windows 20, whichever you use or we use. So that's why the input argument, blah, 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 and not belong to the same data center. So now it has that red error, but doesn't let me go ahead and migrate. Suppose I still try. Okay, so what if it has? Try not to have the mapping of the ISO. Just remove that. I'll show you how to do that too. Next, if I go, it doesn't let me go ahead now. So it says select a validation compute resource. I have selected a valid compute resource. I want to go take this virtual machine to E6i3, right? And it is valid, but it says, so this error has nothing to do with why we connected and Windows 2019 or 2022 ISO to the CD DVD of the virtual machine. But if you remove that, then this error will be gone. So it's related, but it doesn't show that at all. So in one class, we were stuck way back. So then all the students started doing Google. I said, okay, let's Google it. And then one student found in one forum, third page of the forum, at the last line, hey, remove that CD DVD ISO from the, and then it will migrate. And we all tried that, and it was like, seriously, that was so ridiculous. Anyway, I'm just going to cancel here. So I cannot go ahead because the ISO is attached. So how about I detach that ISO and try again, right? I'm just going to right click here again and go to edit settings. Yes, there's ISO. So I can change that to client device. So then no more ISO is attached there. In previous versions of VMware, even if we do this, even if you do anything else, it won't let you go ahead if once it saw this error. Then you restart the machine. Sometimes it's stubborn and still detects that even if you've removed it doesn't. But newer versions are more stable now in this particular way, that if you remove the ISO attachment like this, then it lets you go ahead. But it's still we have yet to see. So I'm just going to press OK after removing that. Then I'm going to again try to migrate now. Change computer source only. Next. And if I click now it says it's okay. So that's the error that I wanted you to see, that you have to remove the ISO mapping from the CD/DVD of the virtual machine. Okay, that done, it lets us go ahead and migrate. Okay, let's go ahead with migration and next. And then it says, hey, you're traveling across the data centers. Remember, we are in the Tor DC data center, and this is NYDC data center. Other hypervisor is in. So it says, hey, just make sure that the virtual network setting, which you already have in Tor DC or this data center, is the same in the other destination data center as well. So we know that, yes, it is same because it's just a warning, right? So it's okay. Next. And there you go. So it's going to migrate now. So what we're expecting is this virtual machine will no longer be in E682. It will be in E683 now. Migration, right? So I'm just going to click finish and relocate virtual machine, completed. And there you go. It's there in E683. So we migrated. Yay. Okay. Yay. So now let's power it on and then suspend it. So that's the second migration here. Suspended, right? So we're going to power on the machine, then we will suspend it, and then we're going to migrate. If the processor configurations were different, we would not be able to do that. Obviously, ours is same because it's just one laptop on top of which two hypervisors are there. So obviously, it's the same. CPU, I'm just going to power on the machine now. It's this one is the one that has an operating system inside, right? So that would be the best case scenario for testing migrations. But if you do that same for the empty virtual machine, it's going to work the same way. But it's always recommended to have the VMware tools installed in the virtual machine if you're trying it with an operating system. You must have VMware tools always installed. Okay, anyway, it's powered on, and then I'm going to right click again, and I'm going to go to power, and I'm going to go to suspend virtual machine, right? Suspend selected virtual machine, yes. And suspended virtual machine. It's suspending. Once it is suspended, its icon changes to equal sign vertical equal sign. Now we're ready to migrate this virtual machine back from 3 to 2 across data center. So right click here, go to migrate, change configure source only. Next. My destination now is E6I2. This section is really important. Compatibility check succeeded. So that's good. Yes, it's a source data center, and we know that source network is same. It's okay. Next. That's it. Now we're expecting this suspended virtual machine from 3 to 2. Finish. All right, now it's here. So migrated back to 2. And now the main feature that is that the power machine, the virtual machine is on, and then we migrate it, right? So I'm just gonna right click and go to power and power on. Now it's just green icon, which means it is powered on. So here, Once it is powered on, we want to migrate it from 2 to 3. So I'm just going to right click. Now we know the drill. So just go to the migrate, right click the virtual machine, go to the migrate, change compute resource only. Next, our destination now is 3. So this is green, we're good. Next. Yes, across data center, we understand. Next. Now it says schedule vMotion with high priority. vMotion receives higher CPU scheduling preference relative to normal priority migrations. So vMotion might complete more quickly. So you want to give a boost to it. You want to reserve more processing. You tell the processor, hey, processor, you're going to pay special attention to all the processes that are being created as a result of this migration. So, hey, Mr. Processor, just do this work faster. If you select this option, otherwise, normal vMotion, it's going to be the normal vMotion, a bit slower. We're going to go faster here and we'll select that and we're going to click next. And finito. So it's supposed to move from there to here. That was, well, kind of 3 or 4 seconds, right? Or maybe 5 seconds. But it says 16 millisecond. It was queued for 16 millisecond. Anyway, so migration is successful for vMotion as well, which is a yay. Okay. Now, if we go back here, so there's the cross-host vSphere vMotion, which includes the third number migration and fourth number migration both. So these two are, as I mentioned before, that you change virtual machine from one hypervisor to another, you move virtual machine from one hypervisor to another, and you move its virtual disk from one data store to another data store. So it's going to happen, well, it's going to happen one by one, but in the same session, in one go. So how do we do that? Now remember that virtual machine itself is only 6i3, right? But I'm on the correct view here. If I go to data store, if I click the virtual machine and click the data store, right? So it is on LAN 1. So in this cross-host vMotion, we need to do both. We're going to move the virtual machine from hypervisor 3 to hypervisor 2, while its virtual disk and virtual files, which are living in LAN 1, we're going to move it to LAN 2 or LAN 3, whichever, right? But away from LAN 1. And both will be done in one session. So virtual machine will change hypervisors, its disks, and and virtual machine files will change the data store as well. Okay, so right click here, migrate. Now we're going to go for the third one. Second one is that it just changes the data store, right? So we're about to do that anyway. So change both compute resource and storage. So as I explained, so I'm just going to click next. It's going to ask now which compute resource you're going to go for. So we are in NYDC in under E6i3. So we want to go to ToorDC and E6i2. This is our destination. Compatibility succeeded. Then it asks that which data store you want your virtual machine, virtual disk, and virtual files to move to. So you don't have to really do that if you don't want to do that, but how to do that, that's what we're doing. So suppose I want to go for LAN 3 for no particular reason. I'm going to click next. It says compatibility succeeded. It's green. That's the main thing. And then it says the same thing. It's across data store, check the network. And yes, I want to schedule it with high priority. Next. That's it. So now 2 migrations will happen and finish. So this should go LAN 3 and this should change hypervisor, right?
I have a question.
Yeah.
If power goes down while this process is happening,
Yeah, if something goes wrong, so the virtual machine stays where it is, or which means that suppose it's going on and somehow the network is not available now. So it just comes back to where it was. It just, what happens in the background, especially for virtual disk. When we say that virtual disk moves from one hypervisor, one data store to another data store, so it actually makes a copy of this virtual disk here while the original one stays here. And then when everything is confirmed that the actual virtual disk fully reached here successfully, then it simply deletes the copy of the disk here, right? So that's how, if there's a sending network issue, because if the storage 200 GB disk is moving and halfway the LAN is not available, then obviously some data will be lost, or the disk will go corrupt. So it just copies everything. And if it gets, suppose it was copying and then there was something wrong here on the network, so at least the original one is still intact. Just the copy data was dropped. So for virtual machine itself, it's a very small data. So it just simply comes back with this on the RAM, right? So it's move and copy. It's sorry, copy and then delete. That's the operation going on when we say move. Uh, oh, seriously. Now, oh, serious. You know what happened? VM01 has an operating system, right? And I gave it 10 GB RAM. So that's not fair at all. It's very less RAM given to the vCenter, so it's going to take forever. If it was a empty virtual machine, so it would have gone faster. Now the virtual disk is moving from one data store to another, and it's a 10 to 12 GB disk. And the RAM and CPU is very less. So it's gonna take a long time for that. Well, we're just waiting for this. Okay, it's done. So that's good. And so that migration now LAN 1 has changed to LAN 3. and the machine has moved from hypervisor 3 to hypervisor 2. So that's V motion and four types of V motions, and the background and everything about V, Mo, and Sun. So, well, the next topic would be cluster. So it's gonna be a little bigger topic, a bit bigger. So let's take a break and then continue with the next topic. That's going to be much longer as well. Resume. And when you're exporting, you click on the virtual machine and then you go to then you go right click and go to the template and export OVF template. That means you want to export it, and that's how it stays there. I can hear myself. Okay. All right. So right. So let's go ahead, guys, and we're going to be talking about now that cluster. And okay, so one more thing is that we will take a screenshot of the that's it. So we're going to take a screenshot of our environment where the vMotion configuration is saved. So where's the vMotion configuration saved? If I go to the hypervisor 2, so it's VM kernel adapter and there's a vMotion. So this is the screenshot number 1 that we're going to take. And those who are not attending the class today, when you are following the video, then you have to take a screenshot of this. If you don't attend the class, you don't upload the screenshots later as well, then obviously you won't get any marks for that day, for that lab. So, okay, here, what we're going to do is we're going to take a screenshot of E6I2, VM kernel adapter, and this VMK1. So we select this, and then we select this. So I'm just going to take a screenshot of this, and it will be, vMotion works. The name of the screenshot would be that vMotion works. And oh, okay, I was supposed to that. Okay, so that would be screenshot 1, vMotion works. I'll just take that screenshot. Actually, here. I'll take this and go for All right, so screenshot one, vMotion works. And now we go for the next topic. And that is cluster. Yeah, so cluster. And then we will have other, within cluster, there are lots of features, advanced features there. So so what is cluster first? So cluster is a group of hypervisors um, where uh, it offers the following disaster recovery and business continuity features, right? So HA, DRS, FT, EVC, vSAN, right? So those are the features that are disaster recovery related and business continuity related features. So it's high availability and distributed resource scheduler and fault tolerance and EVC vMotion compatibility, right? Seriously, what's wrong with me today? So vMotion compatibility, oh man, seriously. Sometimes, VMware EVC. Oh, not CVC, EVC. Enhanced series. So I forgot the enhanced one. Enhanced vMotion compatibility and vSAN. So it's just virtual SAN. Okay, so here we're gonna create a cluster, and let's create a cluster. So create cluster is first thing. Then the second thing is to add the two hypervisors to the cluster. Third thing is make sure all errors are gone, if any. Once and then let's enable DRS and HA features and HA. Let's explore DRS and HA features. So we're going to create a cluster, and if we go to our environment, so what happens is that the hypervisors must be under one data center to be added to a cluster. A cluster works under data center. So each data center will have its own cluster, right? And whatever hypervisors are inside a data center will we will be able to add them to the cluster. But what we cannot do is that if one hypervisor is in one data center and the other hypervisor is in another data center, then we cannot. So like this, the TORDC is a data center and E6i2 is here. NYDC is a second data center and it has its E6i3 hypervisor is here. What we cannot do is we cannot we can create a cluster under data center, right? So if we right click here, so new cluster. So this right click, this feature is if I go to data center and go, new cluster is here, right? So this feature is available under a cluster. So suppose you create a cluster here, so you can only add E6i2 here because E6i3 is under another data center and it can have its own cluster created. So what we're going to do is we're going to move the hypervisor 3, E6i3 to TORDC, so we could have two hypervisors under one data center. So when we create a cluster, the two hypervisors could be added to that cluster, right? So if you have a cluster here and one hypervisor here, so other hypervisor cannot take part in that cluster unless this hypervisor is also part of the same data center under which the cluster was created. So what I'm going to do is, or what we can do is, we can move this hypervisor into the TORDC cluster as well, or move that hypervisor to that cluster data center. So whichever you want. I'm just going to go for hypervisor 3, and I'm going to drag this on top of the TORDC because I'm adding this hypervisor to this TORDC data center. So when we create a cluster, the two hypervisors could be added to the cluster under TORDC. So I'm just going to drop it here, and it's going to just move across away from an NYDC New York Plus data center to Toronto data center. So I'm just going to, if you just collapse the two, you won't be able to see the virtual machines. So then you see that, okay, under this TORDC now there are two hypervisors. Now I'm going to create a cluster under TORDC and then add the two hypervisors to that cluster. So I'm just going to right click TORDC and go to new cluster. Why are we creating a cluster? Because we want to introduce some advanced disaster recovery features and business continuity or high availability features to the hypervisors, right? So I'm just going to create a new cluster under TORDC. We could create that new cluster under NYDC as well. So we chose to create it under TORDC. Now, as soon as you create a cluster, you need to name it. And then whatever features you want to enable, you can enable those. So DRS, HA, and vSAN, right? So FT and fault tolerance and EVC they are also present within the cluster, and we can enable them separately. Okay, so I want to name this cluster. I'm just going to name it TOR cluster, right? And I'm not enabling any feature for now because we're going to enable separately, one by one, those features, right? And then these services will have default settings. These can be changed later in the cluster quick start workflow. Yes, we're going to change them after the cluster is created and the hosts are added. Second thing is manage host with the single image. So this is just with this option, all hosts in a cluster inherit the same image, thus removing variability between hosts. It also brings more features like hardware compatibility. So image of ESXi7 should be the same in all. It should not be that suppose E6i2 has E6i 7.0.1 and E6i3 should have if it has E6i 7.0.02. So if E6i2 has 7.0.1 and if E6i3 has 7.0.2, so they will have different versions. 7.0.2 would have more features than 7.0.1, right? So all hypervisors should have exactly the same image. Okay, I'm just going to press O and K here. And the cluster is created now under the data center called TOR DC. And once the cluster is created and we click the cluster, once we click the cluster, then you will see that it says cluster basics, no selected services, add host. That's the first thing, is that we have created a cluster. We did not enable HA, we did not enable DRS, so it says no selected services. We will be selecting these two guys here. But before that, we need to add hosts, and then we can configure cluster. So we need to add the hosts here. How do we add the host to the cluster? We just we select this 6i2 and drag it on top of our cluster, and then it will be added to the cluster, just like we added to the VApp, just like we added the host to the resource pool. So I'm just going to select this E6i2. I'm going to drag it and drop it on top of Tor cluster. And it says here, this host has nested resource pools. VCP7 is not enabled for cluster Tor cluster. Moving a host to this cluster will collapse all existing resource pools for the host. So remember that we created a resource pool. So that resource pool will, suppose it was configured, then the resource pools will stop working once the hypervisors are added to the cluster. Why? Because we don't need resource pool. We will have a feature called DRS, and DRS does manage exactly like resource pool, but on a very large scale and a fully automated way. So we're going to discover all that. So we say that, yes, we don't need resource pool because now we're getting a DRS feature, which we will explore. So press OK. So it is added, the hypervisor is added under the cluster, in the cluster. So I'm just going to collapse the cluster, and you can see that only E6i3 is shown outside. I'm just going to select, I will select now E6i3 and drag it on top of the Tor plus and ter as well. Okay. So one more thing is that your first name VM01. Now this machine is powered on. I don't want any virtual machine powered on right now. One more thing is that now you see another set of virtual machines that are being created are called VCLS. So these virtual machines actually run the cluster, right? And you're going to see these virtual machines automatically getting created. If these virtual machines are powered off, then the cluster will not work. These virtual machines run the services of the cluster. They are automatically created once the cluster is created. And so if I go to the virtual machine and template section here, this one, and go to Canada and go, this is the folder, this is the data center, and then discover. So there's the VCLS folder here. If I expand that to, so it shows a VCLS virtual machine, which actually is power on virtual machine, automatically powered on the virtual machine as well. I just selected it, I clicked it. So it has to be running if you want the cluster services to be running, right? So that's, then you can see now VCLS2. So another virtual machine is getting created now. And whatever number of virtual machines it needs, it will create that for the cluster to basically run. Basically, it creates 3 machines for the cluster, and then it just runs it, and then the cluster gets it. So that is an automated process that it creates a machine and powers it on automatically, right? But they're there. So that calls for one more thing. If those virtual machines are getting created that will run the cluster, so we need then more RAM, right? So if I click the summary here, this one for this VCLS virtual machine, so it is on E6i2. E6i2 has just 4 GB memory, and that's not enough. So what I'm going to do now is I'm going to have to shut down these 2 hypervisors, and it's going to increase their RAM from 4 GB to 6 GB each. So here, what we're going to do now is just for the clusters and then the next labs to be working properly, we're going to increase RAM from 4 GB to 6 GB. For these two hypervisors only, because we're going to be experimenting on them. So in order to do that, we need to shut down V6I2, change the RAM from 4 GB to 6 GB, and then power it on. And then they do the same for V6I3 as well. So I'm going to do that now. I'll go to E6I2 here and shut down guest, shut down, and then E6I3, power, shut down guest, shut down. So it has 4 GB. So E6I2, 4 GB. I'm just going to click that, and it's going to be 6208. You can just directly type here as well, just to increase it to 6 GB. And yes, it's 6 GB now. Power on A6I2. I'm just going to go for 6I3, click the memory here, and then just type here 6208 and click anywhere here. So it shows now 6.1 GB, which is okay. And press OK and power on. Now, uh, so once they're both started, so here the VCSA has 10 GB, and if I just yeah, it has 10 GB, and these two will have 6 GB now. So it's already 22 GB plus 2 GB, 24 GB now. So that's where more RAM is needed for laptops overall. Now this is starting 6 GB. Obviously, hypervisors, you have to run virtual machines, so the more RAM, the better. And the VCSA, that obviously will consume a lot of RAM. It's a pretty huge machine. So the more RAM you give to the virtual machine and its hypervisor, the better. Always keep hypervisors RAM more, 2 or 4 GB more than the VCSA virtual machine's RAM that is being hosted on E6I1. Okay, both are trying to go ahead. Yeah, pretty much 6I2 is about to finish. Okay, site 3 is also there. So if I go back to this and then go to hosts and clusters here, so it does detect E6I2, but E6I3 needs to be still detected. If I go there, it's still loading, and E6I2 actually also it still is loading, but it was already there on that. Okay, it detects now both the machines. And VM01 was started when I shut down that host, and VM01 shut down as well. Okay, so VCLS, which are cluster virtual machines, cluster supporting virtual machines are also powered on, and we increase the RAM of the hypervisors as well. That should also benefit us in terms of running the cluster smooth. So what we can do now is we can go to Tor cluster and then configure of Tor cluster. Before that, if we go to summary of the Tor cluster, and there are no warnings or errors showing here yet, and it shows that how much total RAM the cluster has. Cluster actually sees the RAM of whatever hypervisors are there. It collectively sees the RAM of the hypervisors. So you can see that the cluster shows that it has 12 GB RAM, right? This is because 6 GB RAM of E6I2 and 6 GB RAM of E6I3. So it just cluster sees the collective total resource here, how much total RAM I have, which is just a, collectively gathered from whatever number of hypervisors added here, and how much CPU it has. So it's the number of hypervisors CPU collectively it sees there, and the storage as well. So I've selected Tor cluster, then I'm going to go to configure, because now we're going to enable these features of availability and DRS, distributed resource scheduler. Now, when we put the availability to on, it is off right now, turned off, right? And not available. So we're going to turn it on. As soon as we turn it on, what happens is that so here, VCSA, as soon as we enable HA here, or high availability, actually it's called just availability here. So it sends, as soon as you power it on, it or turn it on, it sends its availability agent here to the hypervisor, and whichever number of hypervisors were added to the cluster, it sends its availability agents there. Those agents, once installed, they report back. Uh, these agents then are the means of communication, and they also report that what is the health of this hypervisor in terms of availability. Is it available, this hypervisor? Is it powered on? Is it healthy in terms of enough CPU and RAM is available to make it run? So all that kind of health report, and whether it's on or off. So these kind of availability reports are sent as heartbeats by these agents. So we're going to power on, we're going to turn on this availability feature or high availability feature, and then it's going to start pushing some its agents into the hypervisor, so it could know the health of the hypervisors there. So I'm just going to go back here, Tor cluster, and then configure, and then vSphere availability. And here we need to go to, so vSphere HA is turned off, so we're going to just go to edit to turn it on, right? So we come here and you can see that vSphere HA is disabled. So I'm just gonna enable that, and now it is turned on. As soon as it is turned on, in the background, the agents start getting deployed over the network. Some movement is tracked here as well. You can see that configuring vSphere HA. It says now on E6I2 and E6I3. So installing vSphere HA agent on E6I2, installing vSphere HA agent on E6i3. So it could get all the health report and basic availability status updates all the time as heartbeats. So we have turned it on. We're going to turn on also proactive HA, but to enable proactive HA, you must also enable DRS on the cluster. Okay, so DRS is this, and we're going to check that. What is the purpose of availability, proactive HA, vSphere HA, and proactive HA? What's the difference? And then what is DRS, right? So in fact, when we turn it on, this is the correct time to understand also what are those. So first I'm going to go there to vSphere DRS because it says so here. That first turn on the DRS, then come back here and turn on HA as well. Then we're going to explore that which feature is doing what. So I'm going to go for DRS first, and it is off. So I'm just going to turn it on. Then I'm going to come back here and then turn on HA as well. So edit. vSphere DRS. So once it is turned on and press, we're going to press OK here. Now you can see that there are some red exclamation marks showing here. We're going to check it out, but I'm going to go back here to availability, and I need to turn on this proactive HA as well. Now the edit button is no longer grayed out. We can click it on. So I'm just going to click edit and turn it on as well. Save. Right. So in the background, there some movement always is going on, and it's trying to push and then get the updates from the Tor cluster. HA tries to get updates from E6i2 and 3. How is the update? How healthy it is? And CPU and memory, are they working fine? And etc. So now you can see that there's an exclamation mark here also showing. So if I click on this level, it's already clicked Tor cluster, but I need to go and check what are the actual errors that are showing here. So I'm just going to go for summary. And on the summary, it says cannot find vSphere HA master agent. E6i2 vSphere HA host status. It's not clear yet. And then it also says vSphere vCenter server is unable to find a master vSphere HA agent in cluster, Tor cluster in Tor DC. So what is this master agent? So what happens is that as soon as HA is turned on, so suppose you have here VCSA, and then you have here a number of hypervisors. Suppose it's a big environment or different environment, and this is ESXi01 and E6i2, E6i3, oh, 4, 5. But here we have VCSA living here. And these guys are all hypervisors. Inside the VCSA, we have enabled cluster services. Inside the cluster, we have enabled HA and DRS. So that HA, once you enabled it, so it has sent its agents to all the hypervisors. Suppose they were all added to the cluster. We have just two, but I've made here four. Suppose we have four. So now those agents are going to communicate back, but what happens is that one of the hypervisor is actually made a master hypervisor. So master, well, it's not termed as hypervisor, it's just called master. But that's these are all hypervisors, we know that already, and others are called slave hypervisors. So what happens is that whichever hypervisor becomes the master hypervisor, it may not be the first one, it could be any one of those, and its election is held automatically with their own specific algorithms, and randomly one of the hypervisor is made master hypervisor. So what happens is that slave hypervisors are supposed to send per second I'm alive packets to the master hypervisor. So per second. So and that's obviously heartbeat. So that's a I'm alive per second heartbeat that is sent by the slave hypervisor to master hypervisor, right? So that is the master slave relationship here, that so yeah, they're sending per second I'm alive, I'm alive, I'm alive, I'm alive, right? So the master reports to the VCSA HA that he has. I'm getting those reports of that agents are alive. So yeah, all is good here. And then we're going to talk about now different scenarios as well. That what if the hypervisor is not powered on or cut off from the network? Then how does the agents respond? How does the master hypervisor respond that uh, is not receiving heartbeats per second from a certain hypervisor? Just give me a second, guys. Okay, so yeah, so yeah, that's how it is happening here. That master hypervisor and slave hypervisor. Whenever you hear that term, you should understand then that what are they talking about. Um, so I'll just put that right here. Okay, if we go back here. Now, I could refresh that and the environment should be okay, but it's just that sometimes the agents from HA takes time for communication back from the hypervisors to the VCSA HA service. So these errors might not go away soon. If I go to the hypervisor level and then go to the summary of that hypervisor, so it says that vSphere HA host status, vSphere HA agent for this host has an error. vSphere HA agent cannot be installed or configured. Well, it says here that it cannot be installed or configured. Now, what I can do is I can just take this hypervisor out of the cluster and into the data center, and then take this hypervisor also into out of the cluster, and then it will try to just retrieve or uninstall all the H agents. Then I can put these two hypervisors back into the cluster where HA is already enabled. So HA will try to send its agents again. So this is just uh, if this error is not going away, then we can just shoot like this, that we can take it out of the cluster, agents will be uninstalled, and then we again put back the two hypervisors into cluster, and HA will attempt to deploy the agents again, right? So if I go to cluster level and then refresh here, we could also actually go to this. So on the cluster level, I'm on summary page. I could also just put it reset to green, right? Suppose in the background, the error was there, but then the agent started communicating with each other, but this error here still stays. So that could also happen, that in the background it is resolved, but the error still shows here. So we can, if you think that it's false alarm or this has been resolved, then you can acknowledge or reset to green. But after acknowledging and or reset to green, it comes back again. Obviously, then the problem is still not resolved. So refresh, no, it's not going for me. So what I can do is I can just reset to green. I'll try to do that. Sometimes it works, sometimes it does not. I clicked it. I'll click this one as well, and I'll click this one as well. But vCenter server is unable to find a master vSphere HA. This I cannot remove. If I refresh back, so the red signs are still not going away. So sometimes it does happen that the agents are not really communicating, or yeah, so the red error is still there. Now there's that monitor. So if I'm on 682, I have that monitor as well, and that's also just saying the same thing, that vSphere HA agent for this has an error. So what I can do is what I was saying before, for this kind of issue, what kind of troubleshooting we need. So I'm just going to take out this hypervisor out of the cluster and put it on the root of the data center. And then it says one or more hosts are not in maintenance mode. Enable maintenance mode, then remove the host from the cluster. If the host is not responding, disconnect the host from the cluster and add it to the target location. So there are two ways to troubleshoot that. One is you want to take it out. You need to put it on maintenance mode. What is the maintenance mode? If I right click here, so it shows this maintenance mode. So in maintenance mode, what happens is basically you cannot run a virtual machine on it. You can then do maintenance, as the word says. You can actually perform some kind of, if you want to do updates, you want to install VMware updates of hypervisor and then restart the hypervisor. So first it has to be put in the maintenance mode. So right now it's saying that you want to take it out of the cluster, you have to put it in maintenance mode, and then you will be able to take it out. So yes, that's exactly what I want to do. So the other way it was saying was that you go to connection and disconnect it, but then you have to add it just like you've added the hypervisor as a new to the data center, right? So both ways can be done. First of all, I'm going to go for maintenance mode. I'm going to put that to in maintenance mode. When it once goes to the maintenance mode, then I'm going to take it out of the cluster. And later I'm going to put it back, right? So maintenance mode, always remember that if there was any virtual machine powered on, you have to either migrate, vMotion it away from this hypervisor to any other hypervisor. Suppose you have 10 or 20 hypervisors, and only this is going to maintenance mode. So you can move the virtual machines to any other powered on hypervisor. Otherwise, virtual machines, it will not go to maintenance mode if there's a powered on virtual machine on it. Okay, so I'm just going to click enter maintenance mode. It still asks that, hey, you want to move powered off and suspended virtual machines. So if you want to move that, it's okay. Otherwise, no, I don't want to move. If it's already powered off and it's on E692, it's okay. Doesn't matter. Even if you power off, even if you move the powered off and suspended machine away from 2 to 3, it's okay as well. So there is any reason to move that, yes, it's okay. So I'm just going to press OK after unchecking that. And there are one or more powered on virtual machines on hosts, E6I2. I think there was one powered on virtual machine here. Oh, no. Remember that VCLS virtual machines were created automatically? Those were there. So it's going to power them off. Those machines are used for cluster, right? So it's going to power them off, and then it's going to put it to maintenance mode. This is the icon of the maintenance mode, right? So once it is on maintenance mode, I'm just going to drag it out of the cluster and put it in the data center. So why am I doing all that? Because I want the agents to be uninstalled, the agents of HA to be uninstalled. And then I'm going to push it back. I'm going to put it back to powered on normal mode. Then I'm going to push it back to torque cluster where HA is already powered on. So HA will send its agents back to this hypervisor. And I'm expecting that the agent's deployment over the network should be successful. Should. So well, this machine is power out now in the data center level. So if I just collapse the torque cluster, now I see this machine is out. So I'm going to right click here and take it out of the exit maintenance mode. I want to put it back to normal mode. Yep, the maintenance mode icon is gone. It is in normal mode. So I'm just going to take out the other one as well, because other one also has the same issue. And if I try to drag out of it, it says the same thing. There are some machines there. I say that, yeah, just, do what you want to do with the machines, the VCLS cluster services machines, and just go to the maintenance mode. So I pressed OK, and I'm expecting it to go to the maintenance mode, refresh. Did it go to the no, it did not enter the maintenance mode. Okay, so I went to the enter maintenance mode again. It says move powered off and suspended virtual machines, uncheck. I don't want to move them. Press OK. And then it says there are some machines, and you can see it's entering the maintenance mode anyway. So press OK. Yes, I can see that it has fully entered the maintenance mode. I'm just gonna drag it out and put in the, now it is out of the cluster, and I'm just gonna exit it from the maintenance mode to the normal mode. Okay, so now both are outside of the cluster where HA is available, and I'll let the background tasks, whatever tasks are going on, to finish. And then once they're all done and the recent tasks area is quiet and there's nothing else going on here, so then I'm going to put first the hypervisor 2, E6I2 into the cluster. As soon as I put it back, its HA service is on now, so it will start pushing the agent again. I hope the agents get installed and don't give those errors. Sometimes they keep giving errors. So I'm just going to drag it again now into the cluster. It says put all of this host virtual machines in the cluster as a root resource pool. Resource pools are currently present on the host will be deleted. It's okay. And it is inside the cluster now, because and some movement has started happening. The agent's installation is going on now. Waiting for cluster election to complete. It needs to decide if it's going to be a master hypervisor or a slave hypervisor. So they are deploying now the agents to that. Once the background tasks are done in the recent task regarding this hypervisor, and if it does not show any errors, then I'll just put the other hypervisor back into the cluster as well. So yeah, this also is another way to troubleshoot if the HA agents are not really communicating and you're seeing the errors for a longer time. Sometimes even then, when you go one by one, it does that. So we can restart the hypervisor and then try again. And the third thing is just disconnect the hypervisor and add it again to the data center and then to the hypervisor, to the cluster again. So it's just trying to do its background tasks. It when there's an election, so at least there should be two hypervisors. I've added one here, and it does show those red circles, but yes, we can also see that there's background tasks going on. So I could just go for and push the second one into the cluster, and the agents on this will also be deployed. And we need to make sure that all the background tasks are finished. I'll just make this window bigger so we could see how many background tasks are happening here. And before these tasks end, we can't do anything. We should not be doing anything inside the cluster. Sometimes we've done this troubleshooting and then restarting and still those red circles don't go away. Then we just carry on with our rest of the tasks. And after sometimes it takes even more longer time for those circles to go away or turn into warnings instead of red. They become yellow. If they're yellow, they're okay. It's just warning, right? So if they're red, then we need to check it out. But if they don't go for a long time, then carry on with our next labs, next tasks. And if they let you do that, then yeah, it's good. And slowly they will go away. It does say insufficient resources here, but I did provide 2 GB more. The total 6 GB RAM is there, so it should be a temporary error. Wow. Background tasks are still running. Okay, completed. The VCLS, the cluster machines, they are saying insufficient resources, and in fact, that's that exact icon here, which means that the virtual machines that help the cluster run are not getting enough resources. What resources? CPU and RAM, right? I so what I can do is I can check out. Okay, now there's one more thing that we need to understand, and that is related to HA. HA tends to do one protective thing. It implements one protective feature right away, HA, that causes insufficient resources. Oh, seriously? Like at once, HA will do so let me just go to that feature that could be the cause of insufficient resources. So let me show you within Tor cluster, if I go to configure, and we were gonna explore all the features, right? So let's go to Tor cluster, then configure, then vSphere availability, and I need to show you quickly one feature which is causing this error. If I click the edit button for vSphere HA, so there's the failures and responses. We're going to talk about all this scenarios, and then there's admission control. Why I'm coming directly to admission control? Because it is so admission control is a policy used by vSphere HA to enforce failover capacity within a cluster. Raising the number of potential host failures will increase the availability constraints and capacity reserved. So what does HA at once do when it is enabled with the help of an admission control feature? What it does is it goes for capacity reservation. HA, as soon as it is turned on, implements capacity reservation. What does that mean? Capacity reservation means that it is reserving one host worth of capacity. Reserving means it's not going to let anyone use that. So now in English, let's discuss that. What am I talking about? So capacity reservation is that if you want to reserve the capacity of a hypervisor. So if I go for another diagram here, so suppose there are a lot of hypervisors here inside a cluster. And these, you want to reserve the capacity. So capacity reservation, right? So what is that? So HA tends to reserve one host worth of CPU and RAM in case of a disaster. Okay, what does that mean? One host worth of CPU and RAM? So what happens is now all the hypervisors are running, right? And these hypervisors, okay, again, ESXi1, ESXi2, 3, 4. So whatever number of hypervisors suppose are running here. So now they all have virtual machines running on top of them, right? So suppose there are 5 or 6 or 10 or 15 average virtual machines are running on all hypervisors, right? So you have a number of virtual machines running here, and okay, so you have enough number of virtual machines running here, and they are utilizing, like on an average day, they're all utilizing 85% of RAM and maybe up to 90% of CPU daily, right? So during peak hours, especially, and on average, also, maybe you have older hardware here, lesser hardware, or maybe users have increased, but you did not upgrade the hardware. So they are really, going up to the capacity, all hypervisors. And if suppose one of the hypervisor actually goes down, crashes, so where will its virtual machine go? So first of all, first responsibility of HA is, what does HA really do? And when does HA really kicks in? That needs to be also understood. In fact, I was supposed to tell you before all that, but there was troubleshooting going on, so I jumped to this topic. But it's all going to make sense now. When does HA kicks in? HA, it kicks in when a host crashes and VMs need to be, emphasis is on the word restarted on the surviving hypervisors, right? So it kicks in when a host crashes and VMs need to be restarted on the surviving hypervisors. So what happens is that if this hypervisor goes down, where would these virtual machines go? They have to be restarted on whatever other number of hypervisors are available, because the show must go on, the business must move on, right? So they have to be restarted. And how can they restart? This is shut down. Well, they can restart because their virtual disks are actually on SAN, right? And all virtual machines, virtual files are on SAN. That helps us start. So that SAN is connected to all the hypervisors, right? The LUNs, the data stores. So virtual machines, virtual disk is actually on SAN. So these SAN disks, suppose, are accessible to all hypervisors, right? So when the hypervisor goes down, the virtual machine files were already on SAN, and SAN is connected to these other hypervisors as well. So all they need to do is just restart the virtual machine or start the virtual machine on other hypervisors. So that's the first thing to understand is HA kicks in when a host crashes and VMs need to be restarted on the surviving hypervisors. Because I'm doing a comparison, so I'll quickly talk about DRS as well. DRS kicks in when a host is showing degradation of performance, right? So DRS only kicks in when there is slow speed. Crash, if the host crashes, then HA kicks in. DRS cannot do anything, right? Same for vMotion that I was talking about. And then FT, if we compare with FT, which is fault tolerance kicks in when either a host crashes or active VM crashes. The standby or passive VM becomes active VM instantly, right? So that's FT. Now we're talking back to HA. It kicks in when a host crashes and VMs need to be restarted. Now, suppose we were not doing capacity reservation. Suppose capacity reservation was turned off. By default, it is turned on as soon as you turn on the HA. Suppose it was not there. So what happens is, now these 5 machines need to be started on other hypervisors. But if other hypervisors are already on top of their capacity of CPU and RAM, 85 or 90%, they have all reached the 85 or 90% of CPU and RAM, and a virtual machine that is about to start needs at least 20 25 GB RAM, 16 GB RAM, and even that much RAM is not available. So the virtual machines will not be able to start on the other surviving hypervisors, which are still working, but they are over the capacity. They're really reaching the capacity themselves because there was no capacity reservation. So what capacity reservation does is, so suppose it says that, hey, all hypervisors, from now on, I am doing capacity reservation, which means you all hypervisors can use, suppose, um, up to 80% of CPU and RAM maximum, right? And they cannot use more than that. Why? So 20% of or 25% of CPU and RAM, suppose, or 30%, up to you, CPU and RAM will always be reserved, cannot be used by VMs at any time because it's reserved, right? So you can put it to 75, 25, right? Or 65, 35. So it's up to you. So the thing is that whatever you reserve here is called capacity reservation. And this is mainly for CPU and RAM because that's the most sought after commodity. So the thing is that if those now if the capacity reservation was done and 20% of CPU and RAM is always available here, so at least if the any one host goes down and the virtual machines had to be started on other hypervisors, so even during peak hours when all hypervisors have used up to 80-90% of the total 80% capacity made available to them, suppose they reach the 90% of whatever is available, and this is 80% of CPU and RAM is available, and 90% of that they have reached already. But already, if they reach 90% of that, so 30% of CPU and RAM is still available for any virtual machine to start on any of the hypervisors, right? So the thing is that capacity reservation just makes sure that at least one host worth of virtual machines, uh, if they needed to be restarted on other hypervisors, then there would be enough capacity to at least let them start on the other hypervisors. So that capacity reservation is done automatically by admission control. So capacity reservation is enabled by default when high availability or HA is turned on. HA is turned on, right? Capacity reservation is enabled by default when HA is turned on. And it is one host worth of VM, CPU, and RAM capacity reserved, right? So as soon as HA is turned on inside admission control, so conversion is enabled, and that is inside admission control. Well, inside HA. Okay, that's the path. Okay, so now we hopefully understand that capacity reservation. So why are we getting those errors there? It should make sense, kind of sense, make sense now, because automatically one host worth of CPU and RAM is not available to us now, right? Because admission control capacity reservation has reserved one host worth of RAM. So host failures cluster tolerates. Cluster can tolerate the loss of one host, which means one host worth of CPU and RAM cannot be used now. We have only two hosts. So we're already like stuck that we already have like 6 GB on one host and 6 GB on the other host, and 6 GB is gone already, right? So that's where then I normally what I do is I go for disable this one temporarily or for the duration of the course, I disable it. And when I disable the admission control here inside the vSphere HA and press OK, so it tends to check that out and it knows now that, okay, so both hosts have full CPU and RAM, whatever they have is fully available to be used as before. So, one day, Monday or Sunday, they're going to discover that, or agents will detect that, oh, I have enough resources now, so I don't have to give this error, or insufficient resources error should be gone after some time. Sometimes it doesn't go, or it takes longer time to detect that, oh, I have full resources now, admission control, capacity reservation is disabled. Okay, yay. So then it just tries to discover that, and in our slow environment it sometimes discovers, sometimes it does not. Soon summary, due to unhealthy state vSphere cluster. So vSphere DRS functionality was impacted due to unhealthy state vSphere cluster services caused by the unavailability of vSphere cluster services VMs. Yes, it says that vSphere cluster VMs, which is VCLS, those were not available. And why those were not available? Because I kicked out the hypervisor before. So they were saying, hey, because you kicked out the hypervisors from the cluster, so the VCLS machines were gone. Now we're searching for those VCLS virtual machines. So that's why these errors may tend to remain there. Maybe we could restart. Sometimes we have to restart the whole environment. If you had to do that, then always first restart this machine and don't restart any other machine. When it's fully restarted and logged in, then you go remotely connect. Well, you can just try these three first. First this, because it has the DNS and then it has also the storage. And then these two guys, one by one, right? And then check that if the agents are communicating. Or right now, it's not agent related error, it's just insufficient resources, which it might let us still work while this is still happening. Okay, so we talked about, we're supposed to explore the features of vSphere availability, vSphere DRS, right? So I'm going to go to availability here. They're both on. And what do they really offer? Okay, one thing is capacity reservation, very, very important. That they do, at least you're ready, you're prepared for the loss of one host, right? And even if you lose one host, you're going to survive. Those virtual machines will not be gone for long time, right? They will be gone for whatever time it takes for them to restart on the other hypervisor. It could be 10 minutes, 15 minutes instead of 1 day or 2 days. It's in few minutes the virtual machines of a crashed host can still be restarted on the other hosts, right? So that's a good thing to know if everything is configured properly. Okay, so capacity reservation is one thing that HA does, and it does have more options available as well. vSphere availability, if I go to edit and we first check out the vSphere HA, what features it shows, then there is, okay, so first is failures and responses. So you can configure how vSphere HA responds to the failure conditions on this cluster. The following failure conditions are supported. Host. So host fails. What do you want to with the virtual machines? Host isolation. Host is isolated. Suppose the network switch went down and some hosts were connected to that switch. Other hosts were connected to another switch and they're not communicating temporarily with each other. Maybe it's a physical switch or the Cisco switch is restarting. So that's called host isolation. They're isolated into a broken network. Then there is a VM component protection. So, and then data store with PDL, APD. So we're going to talk about that. What is this? And VM and application. So what are those disaster scenarios where, what are those disaster scenarios where um, if those disaster happens, then what do you want to do with the virtual machines, right? So first we need to understand what are these disasters, and then how do you want to respond? So much VMware already has certain kinds of responses here. So if this happens, restart virtual machines. If this happens, I'm not going to touch virtual machines. If this also happens, I'm going to power off and restart virtual machines. If these two things happen, right? And if this happens, I'm not going to touch virtual machines. So what are those disasters then? So the first one is, okay. So the first one is that host failure response. If I expand that, so it says that if allows you to configure host monitoring and failover on this cluster. So this is what we talked about as the basic purpose of HA, that if the host crashes, then the machines are supposed to start on the other hypervisors, and machines will be disconnected effectively. They will be shut down effectively, and the hosts need to the virtual machines need to be restarted on the other side, on the other hypervisors, right? So that's the first one. And yes, it is correct that if host fails, please restart my virtual machines. Other options are disabled, like don't touch my virtual machines. If they shut down, they shut down. But no, we want to restart if the host fails, right? And then, its features also ask for resources allocated, VM restart priority. So is it really important to restart virtual machines? I say yes. I'm just going to go for highest, that please restart at ASAP my virtual machines if the underlying physical server crashes. So it's the highest priority to restart my virtual machine. Sometimes it is not the highest priority. Maybe you want to do it yourself and first start the most critical machine. Suppose you're not around here or you're busy with something else or some other tickets, then you can change it to highest. Now, and restart condition, resource allocated. So there are some other parameters here as well. But overall, yes, it's going to restart. Then there is response for host isolation. So if the host is isolated, do you want HA to power off and restart virtual machines or shut down and restart virtual machines? Power off is an unsafe option. It happens right away. Suppose you pull the plug, it just turns off right away, right? And then restart. So no guarantee if the operating system services are intact or not, or some file got corrupted. But shutdown, it waits for all operating system services to first properly shut down, and then it shuts down the machine and then restarts, right? But it says that if host is isolated, what do you want me to do? And VMware says it's disabled. Don't touch my virtual machines. Okay, what is that situation where you don't want virtual machines to be touched? So if you have a switch here, so suppose there's a physical switch here, and those are Cisco switches, suppose, or Juniper switches. But physical switches, not virtual switches, right? So now some hypervisors are connected to this switch, and some hypervisors are connected to this switch, and these two switches are connected to each other. Now, for some reason, this got disconnected. So now they may be connected. Suppose there's another physical switch here as well, and we know that there are multiple network cards there, right, with the machine. So suppose the hypervisors, that these two hypervisors are not communicating with these three hypervisors, we get that But these two hypervisors are connected to this switch, which is connected in turn to this switch, but they have disconnectivity. But these two hypervisors are also connected to this other switch, and maybe they are connected to some other switch here as well, right? So through this switch, these hypervisors are connected to VCSA, but these two got isolated, but they're connected to other switch. Now that other switch, okay, try to understand this one thing. Suppose the connection that goes through this switch was administrative connection. You were just remotely connected to the switches, administrative connection, right? Suppose this was the administrative connection, and now remotely from VCSA, you cannot see those switches. You think they are isolated. And this connection is actually clients slash users connected, right? So all users may be connected through that switch to all the virtual machines, maybe 500 here, maybe 1000 here, 2000 here, 1500 here, 300 here. So it's, a few thousand users here, a few thousand users here. They're all connected to the different virtual machines, but you are not able to see that because from those switches, you had administrative connection or remote connection to those hypervisors. Now you could think two things here. One is that, okay, I lost connection to those two hypervisors, they're isolated, but are they fully frozen? That's why they are isolated. Like you cannot connect, this means they are shut down, or I am disconnected, but all the other users are still connected. So I should not be touching these hypervisors, right? So that's the situation that could happen. And we should never assume that, hey, we run to the data center, we reach the physical servers, and we just simply shut them down. We should investigate that, okay, I cannot connect administratively to these switches through the VCSA, but there's a possibility that the users may not have been affected. The physical servers are still working. The virtual machines on top of that are still working. And I would then investigate, suppose we know that which virtual machines are here. Maybe their sales department and marketing department virtual machines are normally on E6i4 and 5, right? So you would contact some sales and marketing users. You would ask them, hey, you're working fine, no complaints. They say, yeah, we're good, we're connecting. So then you realize that, okay, so these machines are still, end users are connected to that. My remote connection is disabled. So I would not touch this machine. I would not let HA restart these machines because the agent of HA is still inside, right? So it could just trigger according to the configurations, whatever was configured there. So if I go back to our environment, it says here response for host isolation. If you had put it to this, then if the agents inside with the configurational details copied would detect that, oh, I'm supposed to do this if there's a host isolation, and I think there's a host isolation situation here. So why don't I just trigger that, shut down all virtual machines? So, but we know that the situation could be different and different from what we are thinking, right? So that's why default setting for that is disabled. That don't touch my virtual machine. Let me investigate. Maybe the users are still good. And suppose it was on this setting or the third setting. And, I just got disconnected administratively, but the end users were connected, but this setting was there. So all end users will be disconnected for no reason and all productivity lost for whenever you realize your mistake. Until then, maybe you realize after 2 hours, and the whole productivity was gone for 2 hours, or until you realize your mistake, that you were not supposed to shut it down. They were all okay, only your administrative connection was lost, right? So whoever defaults are okay for a reason there, and we should know what the reason is, right? Otherwise, we can change that anytime we want for whatever reason you think is suitable for your particular environment. Okay, so that's host isolation situation. There's another disaster situation. There are more options here. What you want to do, those three that we checked here are here. right? So, but then there's PDL, permanent device loss, or APD, all paths down. So what are PDL and APD scenarios? PDL, permanent device loss. APD, all paths down. So suppose there's a, not suppose, obviously there will be a this SAN, and SAN is providing you disks after disks over the network, the LANs, right? So these are connected to the LANs, right? All those disks, the software SAN we have, and this is the hardware SAN. Now that's where the virtual disks of the virtual machines are and virtual files of the virtual machines are. So PDL is permanent device loss, means that if you have actually a device is lost, right? These are the physical devices that are lost. So virtual machine, virtual disk is here. If the virtual disk of the virtual machine was on this physical disk and that is lost for some reason, then obviously you have no access to the virtual disk of the virtual machine. So it's going to be frozen. And you can't do anything unless the device is back up, or suppose the files of the virtual machine, the virtual disk, it was also copied on some other physical disk or LAN here as well. And it's just taking time to connect from the crashed disk to its passive or standby disk, which also has the same data here. And it's moving to that. So until this moves is done, so the virtual machine is going to be frozen because you can't access virtual disk, you can't access virtual machine file. Whatever is loaded on the RAM is just not going. It's just going to be frozen in a frozen state. It's the files that make the virtual machine work are there on the SAN, and they are inaccessible now because the device they were on is no longer there, or it's being redirected to a working device, right? So if there's permanent device loss, then they are PDL, so power off and restart VMs. In these kind of situation which I just explained to you, VMware also knows that if you actually lost the physical disk on top of which the whole virtual machine is, then what can you do? You can't do anything. I mean, that virtual machine might not be, most probably it will not respond. It will be in a frozen state. Suppose the devices came back up again and the virtual machine's virtual disk is accessible again. But since the virtual machine is in a frozen state, now you have to go and restart that. Suppose you're somewhere else and for 1 hour you were not able to pay attention to that. So the virtual machine will stay frozen. All users will be, just clicking on the frozen screen and nothing's happening. And so many tickets are getting created. While all we needed to do was just to restart this machine from the frozen state. It's just going to restart and then start again because the underlying physical devices are back up again. So it says here, or it recommends that if in this case, most probably your virtual machine will be in a frozen state. So what VMware by default recommends is to power off the virtual machine and simply restart VM. So it's not recommending shutdown. It's not even there because shutdown is not an option. If the machine is in a frozen state, how can it wait for the services to start? It's frozen, right? So power off is the only option. So that's why it's saying that this is recommended. So The other one is all paths down, which is also recommended as power off. So the situation would be kind of same. All paths mean the path going towards the these disks is actually gone. So suppose the physical disk is okay. It's the path leading to the disk, that connection, fiber optic connection or Ethernet cable-based connection that is going over the network, that is down. Again, it's the same situation. The virtual machine lost its connectivity with its virtual disks and the files that run it. So it will be in a frozen state in most cases. It will be in the frozen state. So in that case, VMware recommends just go power off and restart VMs. Conservative restart policy, and then there is aggressive restart policy. So it's just about how fast you want the restart, how fast you want the power off and restart to happen, right? So APD is all paths down. The paths leading to the disk are down. Same state virtual machine might end up in, which is a frozen state. Users cannot do anything. The only way out of this is restart. And VMware already has the default options on restart, right? So then there's a fifth one is VM monitoring, and it's also disabled. Now this is also there are more of them, VM monitoring only and VM and application monitoring. So what are VM monitoring and what is VM and application monitoring? So suppose you have just a virtual machine here, and that virtual machine you have to put, and that's a best practice also, you've put VMware tools, right? Now those VMware tools, if you enable that option, and this option is enabled, it gets enabled when you turn on the HA. So what happens is that, okay, I need to create VCSA. So what happens is that SXI. So VMware tools actually send heartbeats to the HA inside the cluster, inside the VCSA, right? So VM monitoring is that there are heartbeats per second going on. So per second, I am alive heartbeats sent by VMware tools to HA. So that's happening here. It just says, I'm alive, I'm alive, I'm alive, I'm alive. So for whatever reason, if the VMware tools somehow get corrupted and they, or the virtual machine actually went down, restarted, if it restarts, it cannot send heartbeats, or if it is in a frozen state, right? And it cannot send the heartbeat, or the machine is okay, but the VMware tools got corrupted for some reason and it cannot send heartbeat. So what do you want to do? How do you want HA to react? Suppose it was just VMware tools that was not sending heartbeats, but the virtual machine and application on top of that was okay. So restarting the machine in that case would be a very bad idea, right? And but if it was in a frozen state, yes, then it's a good idea that because it was frozen, so it was not sending heartbeats and somebody had to restart. Since it was on automatic, so it restarted the machine. So it could be that it's a false alarm and it could restart for no reason. Well, the reason is that heartbeats are not coming, but it's not actually virtual machine's fault. Maybe it's VMware tools, which rarely happens. Most of the time, if virtual machine is affected, then it will not send heartbeats, right? So it says that if virtual machine somehow does not send heartbeats, what do you want me to do? So there's VM monitoring, and that means, okay, heartbeats are not coming from VMware tools. I'm going to then restart the virtual machine. Actually, VM monitoring, and if you expand that, turns on VMware tools heartbeats. When heartbeats are not received within a set time, the VM is, there you go, reset. So it's going to restart the virtual machine if heartbeats are not coming from the VMware tools of a virtual machine. It's less possibility that VMware tools are corrupted, but a possibility, but less. It could be a genuine one, legit one, that it needs a restart and then you send. And the other one is that if you go to application monitoring. So if you go to application monitoring, that means VM and application monitoring, VMware tools, and whatever application inside is also sending heartbeats to the HA. If somehow VMware tools and the application inside are not sending heartbeats, HA will think that the application has some issue and virtual machine also has some issue. So then what do you want it to do? You want HA to restart the virtual machine or not? So application monitoring, if you go there, turns on application heartbeats. When heartbeats are not received within a set time, the VM is reset. And that set time you can set here, right? So that's the thing with the failure and responses and 5 types of disasters that if they happen, then what do you want automatically to happen? How do you want HA to automatically respond? And the response is to restart the machine or not to restart the machine. That would be the question, right? So those are the scenarios. And then comes the admission control. We talked about that we have disabled it, but we can enable it as well. The cluster resources are there. You can just decide yourself as well that 50%, 1% of CPU I want to reserve. If suppose you're such a expert in VMware, so you could go for, oh, I'm going to reserve 51% of CPU and 53% or 25% of CPU and 25. So up to you what you want to in terms of capacity reservation, you want to reserve for one host worth of virtual machines, right? That's by default, and we talked about it before as well. Then there is slot policy. Slot policy is that it calculates that how many average number of virtual machines are there, and it automatically calculates that, okay, I find that some hypervisors have 7 virtual machines, some has 4 virtual machines, some has 6 virtual machines. So I'm saying that average there are 5 virtual machines in each hypervisor, and average CPU and RAM that they are using is this and this. So they calculate and then they call it slot size. Slot size means average number of virtual machines using this much of CPU and RAM in average. In all hypervisors, average is, suppose they are using like 64 GB of RAM and 2.8 gigahertz of processing on average. So suppose that is analyzed automatically by HA admission control. So they would consider this as a slot size. And what happens then in the slot size, that if one host goes down, so this much capacity has to be available, has to be made available by admission control. So whatever slot size is considered by automatic analysis, that much capacity is reserved across all hypervisors. So suppose it was 64 GB RAM. So, okay, like 16 GB RAM here, 60 14 GB or 10 GB RAM here, 6 GB RAM here. Total, this much slot size capacity and this much processing and RAM should be available overall by in all hypervisors. So one virtual machine will start here, one will start here, one will start here, one will start here, right? So it's a slot size that, or maybe you're a big expert and you know all the calculations, you're a whiz of VMware, so then you can just assign the slot size yourself. And then there is dedicated failover host. This is the easiest one. You just simply dedicate one host that, okay, from now on, suppose you have there 20 hosts here, and you say that host number 18 will now be always on standby condition. So whichever host you select from here and is added here will be on standby all the time. It will not be used. It will just be on standby, right? So that would be the dedicated failover host. And that host, maybe for next 5 years, nothing happens. Then that host is just sitting doing nothing, right? So preferable way is that all hosts are used, but the capacity is put to such a level so it's reserved, and certain level of CPU and RAM on all hosts cannot be used, right? So cluster resources percentage, so that's what it's called. Now I'm going to go back to, hey, because it's not letting us use the one host worth of CPU and RAM, so I want to use all CPU and RAM, whatever we have, little CPU and RAM. So that's why I'm putting it to disabled, the admission control. Heartbeat data stores, that's another concept of informing. So suppose I select this data store or all data stores. So what happens is that, remember that isolated situation where two hosts are actually disconnected. So suppose there are data stores here. Not suppose, obviously you will have a data stores there. So these data stores are obviously used for storage, but they can also be used to receive updates. Chinmendo, you can upload the screenshots, but I have to, if you have the screenshots ready and you need to go, then you can wait for the class. It's about to finish, just 2 topics left. And then I'll create that upload. Otherwise, you can upload tomorrow if you want, if you need to go. Otherwise, I'm about to finish this. Okay, so as we are talking about that, these data stores here, suppose you are disconnected here, right? So now there is, from this way, VCSA cannot know about the health of these two hypervisors. So they cannot send the I'm alive packets to the master hypervisor, right? So what they can do is they can also send I'm alive packets to any of the data store that you select. They can do that too. And those data stores can report to the master. Those data stores can report to the master. Suppose this is the master hypervisors, and these are all slave hypervisors. So the master hypervisor will get those reports of I'm alive. So data store will report that, hey, you cannot get the report because you're isolated, but we are getting the signals that, and those guys are okay. They're reporting to us, they're okay. And that okay report or I'm alive packets or heartbeats go to the master slave, and master slave then reports to the VCSA that, okay, I'm getting the reports not directly because I'm isolated, but I'm getting those reports from data stores that those guys are good, right? So these data stores can be selected here. They can receive the heartbeats and they can report in log files that, okay, those heartbeats. So those isolated hosts are actually okay and working fine, right? And then there's advanced options, but those advanced options, as the word says, advanced. So basically, the purpose of advanced options area is to, um, make changes to the basic functionality of what is made available here. So you have to then contact the support. You have to, suppose you want to change the default gateway of the environment, or you want to add another default gateway here. So then you can put it with the help of a certain code that you can find in the support files, knowledge base articles, or if you have support contract with VMware, then you can contact the support contract, and that, okay, we want some options by default grayed out here, and nobody should be able to select those, or there should be more data stores that need to be detected here, or something that is you want to change from whatever is actually being offered here. So that you can go for advanced options and contact the support. They will give you certain code there, and you can add that code here, and it will then implement whatever you cannot implement normally here, right? So that's what the advanced options are for. Okay, so make sure that when you're here in cluster settings, you go to admission control and make sure that it is disabled, right? Otherwise, you will have one machine worth of CPU and RAM to play with, and that's going to be too slow and too disruptive, and you won't be able to do some labs. So make sure that this change is done. Other than that, we didn't make any of the changes, but we did try to understand what's going on and what's the actual purpose of the HA, right? So I'm just gonna press OK. Yeah, so this is still going on here. Total cluster, monitor, and the alerts. When you go to monitor and then all issues, so total cluster, then monitor, then all issues, and trigger alarm, it also still says we can give it more time, otherwise we can just restart if it doesn't go away till next class. So it basically says insufficient resources, which well, we haven't given enough RAM, although we have increased the RAM to 6 GB, so should be sufficient. I'll just check that if any of the virtual machines, well, all are off. Virtual machines are off. And if I go to the VMs and templates here, so there are 3 VCLS virtual, or VCLS 3. There's only one machine and that is powered off. If I just power it on, yes. So required to vSphere cluster service required to maintain the health of the vSphere cluster services. Power state and resource of this VM is managed by the. So cluster actually manages the power state of this, which is okay. So I don't need to really forcefully do that. But it just complains about the resources not enough. So maybe it got that because admission control capacity reservation was on. We turned it off, and it should detect that after some time, and then it should let us really work on it. Okay, guys, so this is it. What we can do is take screenshot 2 here, and screenshot 2 would be I'm going to go to availability, and then I'm going to go to edit. So this admission control, and it should be on disabled. So screenshot of the disabled admission control is our screenshot 2. So Tor cluster, vSphere availability, then vSphere HA is turned on, add it, and then admission control, and make sure it is disabled. So this is the disabled screenshot is needed. So we can say that the label of the screenshot 2 would be admission control disabled. So take a screenshot and name it admission control disabled. Admission control disabled. Okay. That's the screenshot too. All right, guys. So let's just upload, and we're gonna continue this topic HA and DRS, and then fault tolerance and EVC. So some more topics will be upcoming. So okay, so go ahead and load. And obviously, guys, here the virtual machine. Just suspend, and I'll open upload. Configure that upload. Suspend, suspend, suspend. O and K. So I'll just oh, okay. I'll just create that upload link. Zero 04, 024.